Our next objective in this section is to solve quadratic equations by the square root method. These steps involve 1, get a constant on one side. So rather than getting it equal to 0, we want a constant on one side. We will get the x squared, or in our case, something squared quantity on the other side. We'll take the square root of both sides. Don't forget the plus or minus. And then solve for the variable and simplify. So for our first example, we will isolate the x squared term. So dividing by 4, so that we see we have x squared equals 2. And we'll take the square root of both sides. And since we have now isolated our variable, this will be x equals plus or minus the square root of 2. Now we cannot simplify that any, so we will leave it as the square root of 2. Our next example, similar process, we will divide by 5. To isolate the x squared, that's negative 4. Then we will take the square root of both sides, and that isolates x. So x equals plus or minus, and the square root of negative 4, recall from our complex numbers section, will be 2i. X equals plus or minus 2i. The next two examples, we need to first isolate or get a constant. Isolating the x squared term is our goal, or our squared term. So for the first of these, we will add 48. So that will be 4x squared equals 48. We've isolated a constant. We have our x squared term now we can work with. Divide by 4. So that x squared equals 12. Now, taking the square root of both sides, you see that x equals plus or minus the square root of 12. Well, 12 is 4 times 3, if you recall. So that our answer is x equals plus or minus 2 root 3. Our prerequisite knowledge is going to come in very useful throughout this chapter. So x equals plus or minus 2 root 3. Now, for our second example on this page, we'll subtract 21. Again, we're getting a constant on the right-hand side. 3x squared dividing by 3. We find x squared equals negative 7. And taking the square root of both sides, this will be x equals plus or minus, and I'm going to write this as I root 7, because the square root of 7 does not simplify. Our last two examples on this objective solve these with the square root method. We're going to, instead of isolating the x squared term, we're going to isolate the, in the first case, x minus 1 squared term, and in the second, x plus 5 squared. We want to isolate this term. So we'll subtract 24. So that we have 3x minus 1 squared equals negative 24. Dividing by 3, we see that x minus 1 squared equals minus 8. Now, we want to isolate the x minus 1 at this point. So we are going to take the square root of both sides. If I remember correctly, yes, I do. The square root of negative 8 is going to be 2i root 2. So this is plus or minus 2i root 2 equals x minus 1. Now I'm going to write this as two equations. I'm going to write x minus 1 equals 2i root 2 and x minus 1 equals negative 2i root 2. My last step is going to be to add 1 to both sides, both of those, so that my solution is x equals 1 plus 2i root 2 and x equals 1 minus 2i root 2. Often more compactly written as 1 plus or minus 2i root 2. Now for our last example, we have less prerequisite work to do. We will go and move straight into taking the square root of both sides. And the square root of negative 36, well, 36 is a perfect square, so this is just 6i. And we have x plus 5 equals plus or minus 6i. I'm going to write this as a set of equations. X plus 5 equals 6i. X plus 5 equals negative 6i. And then we will subtract 5 from both sides. Now, notice, again, I am not combining any terms together. Okay, the I term and that constant are two different things. So I have x equals negative 5 plus 6i, and over here, this is going to be negative 5 minus 6i. This equals negative 5 minus 6i. And again, I can also write that as negative 5 plus or minus 6i. So either of these forms will work.